So, good morning and welcome to this talk about IBM Bluemix OpenWhisk, the future of cloud programming. That sounds good, right? Event-driven and serverless computing with OpenWhisk. So my name is Andreas. I am the technical product manager for OpenWhisk, and today I'm presenting together with Michael. So maybe you want to introduce yourself shortly.
Yeah, my name is Michael Behrendt. I'm working with Andreas on OpenWhisk, and I'm responsible for the technical strategy that we are driving around OpenWhisk.
Okay, thanks, Michael. So having a short look at the agenda first. So I will try to start to give you a very short introduction about what OpenWhisk is and how it compares to more traditional models. And then Michael will tell you a little bit about how OpenWhisk works internally, how we have built it, typical usage scenarios. He will explain a little bit the basic concepts of the programming model, and then I will conclude this session with some demos after we have bored you with so many slides. There's a little bit of time at the end for questions, but also to make that point right now, we have booths out there, so if you have additional questions, just feel free to step by. So, crisp and to the point, what is OpenWhisk? OpenWhisk is an event action platform that allows you to execute code in response to an event. So, think of an IoT scenario where you have sensors that are continuously emitting data, and then each single data point can be seen as an event, and you might want to execute custom logic that you have implemented in what we call an action that encapsulates your application logic in any of the language that we support. OpenWhisk is currently available as managed service or commercial service on top of Bluemix, but it's also available as open source. It's being hosted on GitHub. So, and of course, I would like to take the opportunity at this point in time to encourage you to have a look at our GitHub repository to provide us with feedback, and even better, to participate and to contribute. It's an open technology, so we need you as a community to help us to accelerate the development of all of this. Since September, it's available, the commercial offering is available as a beta program. It's entirely for free. You do not need a credit card. So if you're interested, just go there, play around, and provide us with feedback. You guys know very well what you want to build with technologies like these. We need your feedback to provide you with exactly the right tooling. So we really rely on your feedback. So the key question, of course, is how can a technology like OpenWhisk or serverless technology be better than a traditional model? And I would like to explain that along a very simple, basic example, so to make sure that we are all on the same page. So assume you want to execute application logic or custom code just because something has changed in a database service, like, for example, Cloudant, right? How would you do that today in a platform like Bluemix when you wouldn't have something like OpenWhisk? So you would probably write a little application. The application would contain code. The code would be able to connect to the database to check if there's some change. This little application would then run on a virtual machine or part of a container or something like that. And then to continuously check for changes, you probably would have to do some kind of polling. So you would have to ask the application over and over again, hey, has something changed? Because there is no real event programming model that would allow the service itself, the database service, to tell you that something has changed, right? And this is, of course, bad from a utilization perspective, because that means that this little application is very often waiting for the next request to come in. For the rest of the time, it's idling around. And even so it's idling around, not being executed, the underlying VM, for example, it's still up and running and then costs you money. It's also bad from a scalability perspective, because, for example, if you went with a virtual machine, you are initially at least bound to what you have ordered. But what if load increases? If load increases, you need to answer the question how to scale, so based on which metrics, and how fast to scale. So probably you would end up with the need to set up very complex auto-scaling rules, which is nothing that you as a developer are primarily interested in. It costs you just time. You want to code. You want to get your code running. It's also bad from a resiliency perspective, because to achieve high availability, you would at least need two processes, which is a kind of redundancy that costs you additional money. You probably also want to support something like deployment in multiple regions. that costs even more money. And the fun stuff at the end is you need to keep all of this stuff running and healthy. So a lot of work that you as a developer who wants to focus on coding might not be interested in, and a lot of stuff that takes a lot of operational cost that you are not willing to pay. So OpenWhisk makes things much better. So what we have here is we have the event that I've already mentioned that is supposed to kick off the action that contains the application logic supposed to be kicked off. We call this event a trigger, and the trigger might come from some service. It ends up at the OpenWhisk engine. And from the OpenWhisk engine, we determine the right action that you as a developer has implemented containing the application logic in any of the languages that we support. That's what I already mentioned. And then once we have determined the right action, the magic begins. So what we do is we are able to very quickly deploy these little actions. Then we run these actions, we execute them, and then we throw them away again. So there is never ever stuff idling around. We have a kind of 100% optimal utilization, and that's why you do not need to pay for things idling around, because there is nothing idling around. From a scalability perspective, it's also very interesting because what we can do is we can parallelize the deployment of these little actions. So if load increases, we just deploy more actions. If load decreases, we throw some of them away again, right? So there's nothing idling around. And the entire business of high availability and resiliency, it entirely becomes our problem and not yours anymore. From a more general perspective, of course, OpenWhisk falls into the field of serverless computing, otherwise we wouldn't be here. And that means, very generally spoken, it provides you with a serverless deployment and operations model, hiding any kind of infrastructure and operational complexity, so that you can do what I just mentioned, so that you can focus on quickly developing value-adding code instead of taking care of all these low-level details. It guarantees you an optimal utilization where you do not have to pay for resources idling around, but for the code really being running. And it scales inherently on a per request basis, which means that we at any point in time provide you with the capacity and resources you need to run your application depending on the load that is coming in. It also provides you with a very, very flexible programming model where you can develop in totally different languages. So for example, we support currently JavaScript or Node.js. We support Swift, and I'm really talking about Swift on the server side. So assume you are a mobile developer and you want to outsource compute-intensive tasks to a scalable cloud platform. That's pretty cool because you do not have to learn anything new. You can develop your iOS application in Swift, and then you can outsource some tasks and can embed them into the actions that I've already mentioned, deploy them on the server side in the same language. So we lower the barrier for development. And we also support Python, and in a limited way, Java and Docker, which is also very interesting because that means if a language is not natively supported for implementing these little actions that you want to execute in response to an event, you can package something in a Docker container and just execute a Docker container in response to the event. We have currently also seen that there are community efforts going on that are not only driven by us, IBMers. So people are adding support so that you can code in Go and in Haskell and in Scala. It's very interesting to observe that people are already helping us doing this. And there are also, there's also support for different invocation models. So the little actions supposed to be executed in response to an event, they can be executed synchronously, asynchronously, periodically, so different things that we support here. We also support higher level programming constructs. So for example, we have a concept that we call sequencing. So once you have multiple actions that contain application logic developed, you can stitch them together to compose an overall solution in a declarative way, which usually means you do not have to touch each single action's code and wire them by coding together. You can do that in a declarative way, which feels a little bit like Linux piping, and it's very interesting, of course, to do it that way. We also support something like parameter binding. So for example, you might have credentials, right? You do not want to put the credentials into the action's code. You want to bind that to the actions, but not inject the credentials into your code. And very recently, we have started working on a real-time debugger, which allows you to debug what you have developed. That's something work in progress, but it's already available on GitHub, so feel free to have a look at that as well. That's a very interesting feature, and I think a very big competitive advantage. But the best thing, in my opinion, is that it's an entirely open technology. which means the engine is open. You can take it, you can run it on Bluemix, but you can also take it and deploy it on any other infrastructure, which means that we avoid any risk for any kind of vendor lock-in. But even better, even the ecosystem around is entirely open. I mean, if you have an engine, that's good, but what you need is all these services that emit the events or consume the events. And what we have for you is an open interface of event emitters, which means that anyone, including you, and of course I would once again like to encourage you to do so, that anyone can enable services and make it part of that ecosystem. It's not only us as IBMers who do that, it's even you guys who are able to do that. OpenWhisk has been implemented in Scala, and it's also implemented based on other open technologies. So we use under the hoods, we use Docker, Kafka, Consul, and what we currently are observing, once again, something the community is driving, not we as IBMers, is that there are community efforts to integrate with other open tools where integration just makes sense. So for example, we have an extension for Visual Studio Code. So you can do the creation of the little action, deletion of the little action, invocation of the little action, everything embedded in Visual Studio Code without the need to leave the IDE, which makes developing very easy. You can also combine OpenWhisk with Node-RED. We will see that a little bit later. So a lot of efforts going on in that space as well. And very recently, we have put our Apache Incubator proposal out jointly with our partner Adobe. And I think this is a strong statement that we are really, really interested in making that an open, non-IBM-ish effort. At this point in time, maybe one thing for clarification, because I've been asked that this morning again, is OpenWhisk meant to replace all the other means that we already provide in our Bluemix platform? Of course not. All of these ways that Bluemix allows you to develop your application will remain to coexist and all have their pros and cons. So for example, on the right-hand side, you can still go with virtual machines, and of course there are advantages, because this gives you the entire control and flexibility of the full stack. You can pick the CPU you need, you can pick the memory you need, you can pick the operating system you need. If you don't need this flexibility, because the price for this flexibility is complexity you have to care about, you move from the right to the left, and at the end you end up at OpenWhisk, which makes getting started simply much easier. This is the general story, and now I hand over to Michael, who will explain a little bit how it works behind the scenes.
Okay, thank you. So there are different ways to invoke actions within OpenWhisk. One of them, as Andreas already lined out, you can trigger actions based on events kicking off in various event sources. So there is an event source, for example, called Cloudon, which is a managed service based on CouchDB that we have. You can use push notifications. You can use Kafka, which is something we are working on as an event source. And you can hook up very easily those event sources that are registered with OpenWhisk with the actions that should be invoked in response to that. The other option for you to invoke actions in OpenWhisk is to directly invoke them. So not relying on any event source to have something occurring, but you explicitly calling an API to invoke those actions. You can call them from any endpoint. It can be from a single page app that's running in a browser. It can be from a web app. It can be from a mobile app. The canonical approach you take is there is one URL that you can use in order to post an HTTP message against it. It's JSON in, JSON out, and the action that gets addressed by that HTTP endpoint will then process that request. Like Andreas said, either asynchronously or synchronously if you have the blocking equals true parameter as part of the invocation. So one thing that we started working on now with our partners from Adobe is the integration of an API gateway. It has been touched already on as part of some of the previous talks. The API gateway scenario is a very important one in the serverless context. So we are starting now to work on that. We are basing this on the Adobe API gateway, which is using Nginx. We're using the IBM Micro Gateway to seed this effort. And there is work already going on out there on GitHub to build this implementation. The way we want to build this is in a very seamless fashion. So you don't have an API gateway here and a serverless engine there, but really give the user a single experience in terms of how he creates those APIs. So the way it works is, for those of you who are familiar with the serverless space, this should be quite common. You do, for example, an HTTP GET against a specific URL, and then OpenWhisk receives that, or the API gateway receives that GET, translates it into an invocation of an action. The action does the work, returns back the result, and the API gateway hands the result back to the invoker. What is the API gateway going to take care of? Security in terms of authentication, authorization, threat protection, rate limiting on the control side, mediation, parameter mapping, all sorts of things you would expect an API gateway to do will be done by that API gateway. An example for how we envision the user experience to look like. So on the CLI, for example, you would first be creating an action. Let's say it's a Node.js action, hello.js. You name that action hello. So you just do whisk action create hello.js. And then based on the action that you just registered within OpenWhisk, you would be saying, for this action, I want to create an API endpoint for an HTTP GET /v1/hello. And once you've done that, under the hood, the API gateway would be configured such that from then on, when you hit the corresponding URL, the API gateway would be calling the OpenWhisk action under the cover. So how does OpenWhisk look like overall from an architecture perspective? And we'll look into the white box details in a second. So we have actions that can be implemented in different languages. We talked about them before: Node, Python, Docker, server-side Swift, and so forth. They can be individual actions, or they can be sequenced actions. The package is the construct that allows you to add another event provider. And Steve Fink has a talk later on today where he'll talk about how you create additional packages that represent event providers. The OpenWhisk engine has a REST API that can be invoked or is invoked by the CLI under the cover. It is invoked by the Bluemix UI under the cover. It is invoked by the iOS SDK that we're delivering. So if you want to build a mobile app, you embed the iOS SDK in it, and from there you invoke the REST API under the cover. And in the future, as I just outlined, the API gateway will be calling the REST API as well. Under the cover, we are using lots of Docker, both for hosting the management system, but also for creating actions. I'll talk about that more in a second. So what are the scenarios where this is relevant in total? Obviously, API backends and all sorts of microservices. Mobile backends, so if you have a mobile app for an iOS device, you want to call something on the server side or build something on the server side to augment the logic you have on the client side, you would do it there. Data processing and data streaming in general, be it static data like PDFs, pictures, videos, or also data coming in with streams via Kafka. IoT, as we mentioned before, cognitive scenarios, for example. We have a very interesting demo application, and also one that was just shown in Las Vegas this week, where somebody's using a drone to record videos of the environment, and we're using cognitive technologies to detect hail damage. So if for insurance, that is very useful because they don't have to send around people anymore. They're just recording the environment, and they get automatic hail detection based on that. And chatbots is another very common scenario. One customer we're working with at the moment in the finance industry has a scenario of check processing. So they get lots of checks in the US every day, every week. They need to be scanned, they need to be OCR'd, they need to be processed. So those checks are uploaded, stored. Once they are stored, they they need to be parsed, they need to be OCR'd, they need to be recorded in the system, and this is all done by a number of actions. You see them in green here that are reacting to new data that's coming in on the storage side. So I want to talk a little bit about the insights of how OpenWhisk works. What are the internal components? So it starts all with an Nginx. The Nginx is just the front-end part that spreads the load across multiple components. It doesn't do a lot. It hands over commands, incoming HTTP requests for creating new actions, deleting actions, invoking actions, and so forth, to a component called the controller, which is a Scala-based implementation. That controller, once the request comes in, goes to a database. We're using CouchDB here to see, is this user authorized to do what he wants to do, and to retrieve data. For example, if I invoke an action, it needs to get the code that represents that action from the CouchDB. Then it talks to console. Console is used in OpenWhisk to keep an understanding for what's currently going on in the system. Which actions are executed, which actions are running, how many are running concurrently, so we can throttle traffic. So once the controller determined which Docker host, which container host should be used in order to run an action, he sends the message out via Kafka. It's queued up there. And an invoker receives that. An invoker, think of an invoker as a container host that's running a little piece of code that instruments that container for executing actions as they come in. So the invoker code running on the Docker host receives the Kafka message, executes the action, returns back the result. And of course, we can scale that out, so we usually have many of those invokers to execute actions in parallel. So one of the questions you could be asking yourself, how does this look like in Bluemix? You can see here it looks the same. There is no change in Bluemix. The same code as we have it in the open is running in open source. One difference is we are not using CouchDB as an open source technology, but we're using a managed service based on CouchDB, which is Cloudant as the database to make our life easier. We have an integration service with Bluemix that integrates with the authorization management in Bluemix and the permissions management. That is not open source today, but we are considering to open source it, and we are quite soon actually. And we are using an Elk stack and some Grafana to do monitoring of that system. And we are also considering to open source our configuration there. So one question you could be asking yourself is, when I invoke a Whisk action, is that equal to Docker run? Is it just running a container, or is there more behind it? Well, it's kind of running a container, but there's more behind it. What is the difference? The first step we take when we need to run an action and nothing is there, we need to do a Docker run. That spins up a Docker image, a Docker container, with the runtime in there that was requested. So for example, if you invoke a Whisk action that's based on Node, we instantiate a Docker container that has the Node runtime in it. As a next step, we call an endpoint within that container, which is called init, and that endpoint injects the code for the action into that Node container. So with that, we prepare the Node container to run the action. And then the third step is we call another endpoint, which is called run, which then consequently triggers the execution of that code. So this is a fast process, but it still takes many hundreds of milliseconds usually. And therefore, we call it a code container. This is the case we usually always want to avoid because it takes the longest from an execution perspective. So what we try to cut out here is the Docker run. We do that by preparing actions, preparing containers that have already the runtime included. They are pre-provisioned. They can be reused for any user because they are pre-provisioned and not assigned it. They don't have code running from a user yet. So these pre-warm containers are already much faster, but we also want to cut out the init step of having to inject the code and have a container already prepared where both the runtime is in there and the code is injected. So if a user is running an action very intensively at high frequency, we are reusing that container on a per user basis. We don't reuse them across users, otherwise there would be security problems. So as we go from left to right, we are running containers, ideally in a pre-warmed and warm fashion. Rarely we do them in a cold fashion. We do lots of caching algorithms and pre-warming algorithms in order to optimize the performance. So I think in interest of time, maybe we should switch over to the UI demo.
Yeah, that will explain the programming model anyway.
Yeah, maybe just one thing before we do that. I talked about the debugger, and the debugger, Steve will also talk about that more. It's a very interesting capability which allows you to debug an action that's running in a serverless environment, which is something many people have been asking for. One of our guys on the research side, Nick Mitchell, he implemented that. You will be able to, the code is out there on GitHub, you can try it right now. You can use a CLI tool to invoke an action, to attach to an executing action, to set breakpoints, to change parameters on the fly. All of that is possible. Okay, so with that,
yep.
Hand it over.
So enough slides, enough theory. Let's try to wake you up again, doing some demos. I have a couple of demos here. If you are interested in seeing, for example, how the debugger really feels like and stuff like that, just come to our booth. I can show you all these demos, but in the interest of time, I decided today to just walk you through the UI that we have. Of course, you can also code from within your IDE, and then use the CLI to do all the stuff that I show you now. You can use the extension that I've already mentioned at the beginning of this talk that we have for Visual Studio, plenty of options. But looking at this demo that I show you now, where we do everything in the UI that we have, explains the basic concepts very, very nicely. So let me just start a demo. So this is how it looks like if you access our OpenWhisk UI, and now I guide you through and try to explain a little bit what you see. So we first go to development, and then the first thing you see is that you see at the top left all the actions that you have already created in the past. You can select them, you can delete them, all the sequences that you have mentioned in the past. If you remember, sequences are something that is being created if you stitch multiple actions together. You see all the rules that you have created in the past, which is the association between the triggers and the actions, just the way I explained it at the beginning. And then you have this big area in the middle of the screen where you can put in your code, and the code being in there can be executed within the browser just by clicking Run this action, or you can of course click the button Create an action just to create a new one. You also have access to what we call the catalog. So the catalog is like something which provides you with a shared collection of actions and triggers, making it easy for you to integrate with other systems. We will have a look at that in a second. So for example, there's a package there called Watson, which allows you to work with Watson, for example, to invoke services Watson provides you with. You can also, for each single action that you have already selected, link it into a sequence. This would be the logical first step to create such a sequence. Or you can go to automate this action, which means you would like to associate a trigger so that this action is being fired based on the trigger you have configured by going this path. So the first thing we do is what all developers do. We create a very simple a hello world action, and I decided to do this with Node. Of course, I could also have picked a different runtime. So let's do that. I click on create the action. I give the action a name, hello, and then I pick one of the runtimes being supported. So I go for Node.js version 6. Of course, I can then configure some additional things, like for example, the memory quota or the time limit. I just leave the defaults as they are. Then I click create action, and I copy the code in JavaScript that is supposed to return hello world when being executed in here. I make it live, and then I click run this action, and it will be executed directly here. You will see the result directly here in the browser after I click run with this value. So that was pretty simple. That's all you need to do to write a little action and to get it executed. So let's do something a little bit more complicated, and let's use an action that accepts a parameter, because you might wonder, how can I hand over the parameters if I do that? So let's create a second action. We call the second action hello2. Use the same runtime, so it's again node, and leave all the other values the same than they were before. And we just paste in the changed code. So this accepts two parameters, namely name and place. And then if we click run this action, the system prompts us for the parameters that I would like to hand over. And in this case, it's a JSON object that I pass in. And the parameter names are name and place, and the values for these are Andreas and Stuttgart, Germany. So if I now run with these values are being used to feed the little action that I've just created. And you see the result that we could expect. Hello, Andreas from Stuttgart, Germany. So very simple so far. So the next thing we do is we click the hello action and do this automate thing. So what I now would like to do is I would like to use a trigger so that this action is not being executed because I click this run this action button. It is supposed to be executed because something has triggered it. So we click on automate this action, and we have then plenty of options that we can go for. So for example, we could go for this periodic trigger. And at the very beginning, Michael and me already mentioned that we have this capability to execute actions in a periodic fashion. So let's try this as one example. And if you are interested in the other example, step by at our booth and we'll show you the others. So I click periodic, and the next thing I have to do is I have to click on create a trigger, and then I can pick different options. So I can say, okay, I want to execute this hello action on a per minute, per hour, or per daily basis, for example. I go for minutes, and I say I want to execute this every single minute. And then I create a periodic trigger. First, I have to give it a name. I call it my periodic trigger. Click on create periodic trigger to create it. And then I say, okay, next. And then I get a little visualization of what I have modeled here. So this says, if the periodic trigger fires, then invoke this action, and the action is called hello, exactly what I want to do. I save the rule. Now trigger and action, just the way I've explained it before, are being associated. And now what I can do is I could select this, or I could go to the monitor. And the monitor is a kind of dashboard where I see at the top right, it's the only part interesting for now, all the past activations that have happened. So now what I do is, and now the video is cut so that you don't have to wait for 4 minutes to see 4 activations. So what I do here, I see, okay, the last thing that happened here was at 9:47. So now I cut the video, then I press the refresh button several times, and you will see that the trigger will fire at 9:48. So at 9:48, the trigger is fired. Due to the fact that it's modeled as part of a rule, the hello action was invoked, and you see the result hello being appearing. So I do this one more time just so to believe me. So there should be another invocation at 9:49. Yep, and there it is. So very, very simple, right? There was not much code that needs to be written. So let's do something different. So Michael already mentioned that there are different ways to invoke an action. There's a way where we just model a rule and the action is being executed because something has emitted an event. But of course I can also invoke it directly. The question is, how can I do that? How can I know what the right endpoint is? So I can click on this view REST endpoint thing here. And if I do so, I see all the information I need. I get information about the endpoint that's here. And to test it out, there's also a curl example that I can just copy. So I copy the curl example, fire up a shell, and paste it in there. And then this should also respond with hello world. This is the way of calling the action directly without having a trigger. And yep, surprisingly it works. That's the good thing of using a video. It usually doesn't fail. But if you want to see it live, step by at our booth, because of course it works also live. So the next thing that we would like to do is, sometimes things do not work as expected, right? So you might wonder, how can I find problems? So of course we also support some kind of logging. And I just added a log statement, and now I run this action again, something very basic. And you might have already seen it. At the very right here, there is this show logs, and you can also see the logs and all the log statements you have added to your code, which makes developing and finding errors much easier. So the next thing I would like to do is, I would show you a little bit about the packages that we have. So I just opened the samples package, and what you see if you access a package, it gives you a short description of what this package is able to do, and you see all the triggers and actions that package provides you with. In that case, it's only actions, so there's an action for doing a curl, echo, greeting, whatever, and there's also an action that is called word count. If I click on word count, I get a short description of what this action is supposed to do, so it counts words in a string. And if I want to get a better understanding of what it does, I can click on view source, for example. Then I see the source of whoever has implemented that. I can just see it. And then the next thing I can do is I can click on that again, and oops, yep. And then I see also sample input. Then I can, oops, let's move that away, that I can use to feed that particular action, and I also see the output that I can expect to get. So let's feed this word count action with OpenWhisk is super cool, and let's invoke it, and the result is 4, just the way I expected it. I haven't to code anything, I just use that stuff that we provide you out of the box. So let's do something different. Let's write a little action that we call echo, and we will need that echo action in a second. That's some of the last things we do now, just in the interest of time. So we write a little action, it's called echo, and echo is doing nothing else than responding with live is, and then appended or concatenated with the payload you hand over, with the key the payload you hand over, right? So, and now what we do is we use the Watson translation service, the same way we have just used the word count thing. So we click on translate to understand how this service works. So we see, okay, it translates some text, it requires some sample input, which tells from which language to which language you would like to translate. And the first thing you need to do, you need to create an instance on Plumix for Watson. That's something I've already done, so I know my password and all that stuff. So no photos now, please. So I give it a name, and then I pass in my username and password for the Watson instance that I've already created, so that I have a binding that I can use. So no photos now. I will get you. I should change password. I don't trust you. Okay, and then I've created a binding. And now what I can do, I can first test this little action. So I go to translate, I can run this action, and I just put in here, translate from French to English the word wonderful. I do not hand over username and password, I just use the defaults from the binding, and I get back the translation for the word. I mean, I don't speak French, but hopefully it's right. So I get a translation. So now let's model a sequence. So what I do is I go to the echo action that I've just written, right? And this will always return the payload live is plus the word payload that is being handed in, okay? And then I click to link to a sequence, and what I now do is I use the Watson translate stuff I've just shown you. So I go to Watson, I select the translate action, I reuse the binding with my credentials, and then I click to add to sequence. And then I get a visualization about what is supposed to happen. So if the echo action is being kicked off, then the next thing to happen is that it's being connected to the Watson Translate service. So this looks good. Save action sequence. And now I click the action sequence and I just execute it. So let's click it. Let's say run the sequence, and all I hand over is the text wonderful, which means echo will respond with live is wonderful and will hand it over to Watson. It's not much coding, I'm just using all the stuff being there. And then I click run with this value. And hopefully it comes, the result is something in French that means life is wonderful. La vie est belle is Probably right. So this is how you model the sequences, the concept that I've mentioned already at the very beginning. Okay. So the last thing I would like you to show is something different. So let's change the hello action a little bit, and let's say, okay, it is supposed to respond with hello from Git when being invoked. And I would like to automate this again. So what I want to do is that if something changes in Git, so now I use an external system, that then this action is supposed to be kicked off. So once again, I go to automate, I go to Git, because this is supported, I add a new trigger, and I paste in my credentials. So I paste in my Git username, no photos again. I call it my trigger. And my access token. And I say I want to listen to all events. And now I can select from my repository, so the repository I want to watch. I save the configuration. And now, if I go to GitHub, to this repository and make a change, it will fire an event, and due to that, the hello action that I've just changed, which will respond with hello from Git, should be invoked. So let's try that out. I go to Git. First of all, I open the monitor so that we can see that it's really working. And now I go to Git, press this here, make a very quick change, click the commit, and then we hopefully see in the monitor that this has worked. So let's refresh. And what we see is, yeah, it has fired, and we see the message hello from Git. So that's what I wanted to show you. We have a lot of more demos that I've already mentioned. So come to our booth if you want to see the debugger, come to our booth if you want to see the VS Code integration, if you have additional questions. So just to sum this session up here.
It's not projecting.
It's not projecting?
Oh, no, it's coming.
It is. Yeah, I think I close with this slide here. So I would encourage you just to play around, maybe today or tomorrow, because we are around. If you have additional questions, we can help you. We'd would also be very interested in the ideas that you have, in the scenarios that you would like to build. Maybe you have already started playing around and have questions. So if you want to start working with the offering on Plumix, just go to this URL here, console.ng blah blah blah. Once again, it's entirely for free. There's no risk, no credit card that you need. Or have a look at the open source offering. Maybe you want to deploy it locally on your own infrastructure. And if you want to have more information, we have a lot of resources out there that you can have a look at. So we have the Developer Center, for example. We have a blog. We have information on GitHub and all that stuff. I assume we'll put a slide deck here on SlideShare after the conference, so we'll find it, and then you find all the links that might be here of interest. I would also recommend to follow us on Twitter. And if you directly want to communicate with the development team, I would recommend that you join our Slack channel. So just go to this URL first to sign up, and then go to this Slack channel and to the channel OpenWhisk, so you can directly communicate. You also find some material on SlideShare and on YouTube. And if you want to know about all the events we have been in the past, you will find them here. If you want to know where you can meet us again, so now that you know us, you probably don't want to meet us again, but just in case, you can find all the dates here. Thanks a lot for having listened to our talk, for having been here. I'm looking very forward to meet you at our booth and to get your feedback, maybe your ideas, talking about your scenarios, because it's an open technology. We need a community like you to make that even better and to direct it in the right direction. Thanks a lot for listening.